The domain and range of a function. Let's look at some other ways of writing these. So you can write the domain and range of a function using interval notation. For example, if we've got a domain written in inequality form as x is greater than or equal to -2, we could write this in interval notation by first considering what's the smallest value of x. Well, if x is greater than or equal to -2, the smallest value is -2, so I can write that. It gets a squared off bracket because -2 is included, and we know that because of the equal bar in the inequality symbol. It's greater than or equal to. Then the largest value that x can have is positive infinity because it's all the values of x greater than or equal to -2. So we write comma infinity, and infinity will get a curved parenthesis. And we use this when the value is not included. And we use that all the time with infinity and negative infinity, or if there's no equal bar with the inequality symbol. Let's look at the range. Y is less than 5. So what is the smallest value that y can be? Well, if it's all the values less than 5, that starts at negative infinity. Negative infinity gets the curved parenthesis. And then the largest value is 5. 5 also gets a curved parenthesis because there is no equal bar included. So 5 is not included in the range. Okay, let's look at another domain. The domain is -2 is less than or equal to x is less than 8. So here, what's the smallest value that x can be? -2. It's included because we have an equal bar. X can equal -2. What's the largest value of x? Well, 8, but it's not included. So here, the 8 gets a curved parenthesis because there is no equal bar with the inequality symbol. Okay, interval notation uses about 5 symbols. It uses the curved parentheses, the squared off brackets, and they can be mixed and matched because you could have one of each. Includes the infinity symbols, negative infinity symbol, and sometimes you'll see union, which is like an OR where we've got different parts of domains and ranges. And then of course numbers. You can also write the domain and range using set builder notation. So let's look at this example that's written in interval notation from -2 to infinity. And let's assume we're talking about domain here. So we could translate this into words as x is greater than or equal to -2, or x is greater than or equal to -2. And the equivalent set builder notation would look like this. So this first part, the curly braces, indicates the set of. Then we have the second part, which is indicating the variable here, the set of x's. This vertical line represents the word or stands for such that. And then we've got our inequality. X is greater than or equal to -2. So here we've got both, well, we see 3 forms. We see interval notation, we see our traditional inequality form, and then our new set builder notation. Let's look at our second example, -infinity to 5. Remember on the previous slide, we were describing the range using this. So here, y is less than 5, or in set builder, well, in inequality form, it's y is less than 5. And then in set builder notation, we would write the set of all y's such that y is less than 5. Okay, here's our third example from the previous slide. So this represented x is greater than or equal to -1 and less than 5, written in inequality form like this. In set builder notation, we would write this. So the set of all x's such that x is greater than or equal to -1 and less than 5. Set builder notation uses the following symbols. It uses the curly braces to designate a set, then the inequality symbols, so less than or equal to, greater than or equal to. And then this symbol, which is like a C with a little line to almost make it look like an E, represents is an element of. We will see different type of letter face like this, representing sets of numbers. This one's real numbers, the set of real numbers. We might also see these other letters designating integers, rational numbers, natural numbers, whole numbers. So let's look at a few examples. Let's find the domain and range of each function shown here. So for this first one, we do need to notice that it does have it looks a little different than what we've seen. So let's look at the domain. Remember, the domain refers to the x values. Okay, so we're looking for the smallest x value first, and this arrow indicates that the function keeps going up and to the left, so it's eventually going to get to -infinity. And if we go to the right, it ends at this point, and the x value of that point is 8. And it has a filled in circle, so it includes that point 8. So we could write the domain is the set of all x's such that x is less than or equal to 8. And we know that it has the equal bar because of that filled in circle. Interval notation, it would look like this. The smallest x value was -infinity, which got the curved parenthesis, and it goes up to 8. And because of that filled in circle and the equal bar, the 8 is included in the domain, and so it gets the squared off bracket. Let's look at the range. So remember, the range is the y's. So it goes up again to +infinity, and it goes down again to our point 8, -2, so our smallest y value is -2. So here we could write that the range is a set of all y's such that y is greater than or equal to -2, or in interval notation goes from -2 to +infinity. Okay, let's look at a second example. Here we've got a quadratic or a parabola. So let's look at our domain. So remember, that's the x's. It goes up forever and to the right forever, and up forever and to the left forever. So it goes out to -infinity and +infinity. So here we could write in set builder notation that the domain is the set of all x's such that x is an element of the real numbers. In interval notation, it's written as -infinity to +infinity, and both ends here have parentheses because they're infinities. The range, here we're looking at the y's. Again, we've got the arrow to show that it goes up forever. So our highest y value is +infinity, but our lowest y value is down here at 2, -1, and the y value there is -1. So we could write our range as the set of all y's such that y is greater than or equal to -1. -1 is included, so we have the equal bar. Or in interval notation, from -1 to +infinity. -1 has the squared off bracket. Infinity, of course, has the curved parenthesis. Let's look at a third example. So for our domain, again looking at the x's, here we have an open circle. So while the lowest x value is -1, that -1 is not included in the domain. And our highest value here at 5, 3 has a closed circle, so 5 is included. So the open circles mean the point is not included. Closed circle means the point is included. So it goes, we have -1, we have 5, we want the x's in between. So the x's are the set of all x's such that -1 is less than x is less than or equal to 5, or an interval notation from -1 to 5. And the -1 has the curved parenthesis because it's not included, as well as no equal bar. The 5 has a squared off bracket because it is included, as well as the equal bar, depending upon the notation. So for the range, let's look at the y's. So our lowest y is going to be at 1, but not included. Our maximum y will be at 3, and that will be included. So we could write the set of all y's such that 1 is less than y is less than or equal to 3. Or an interval notation, it goes from 1 to 3, with 1 having the curved parenthesis and 3 having the squared off bracket.